What volume of oxygen will remain after reacting 8 cm cube of hydrogen with 20 cm cube of oxygen? Solution. To attempt questions like this, we'll be making use of gay-lussac's law of combining volume, which states that when gases react, they do so in volumes which bear a simple ratio to one another and to the volumes of the product if gaseous, provided that temperature and pressure remains constant. And another thing to note when applying gay-lussac's law of combining volume is that it is only applicable to gases only. That means the reactants must be in gaseous state as well as the product. So now we have oxygen reacting with hydrogen. The first thing to do is to write out the chemical equation showing the reaction between hydrogen and oxygen. So for hydrogen now, hydrogen gas, we have that to be H2 reacting with oxygen gas O2 to give us steam, which is H2O. Now, after writing out the equation, next thing to do is to balance the equation. Here we have 2 atoms of hydrogen present. We have 2 here as well. Hydrogen is balanced. For oxygen, we have 2 in the reactant side, and product side we have just 1. So to balance that, we'll be adding 2 here. So now this makes hydrogen to be 4, and in the reactant side hydrogen is just 2. So we'll be adding 2 again. So this makes hydrogen to be 4, and in the product side as well it is 4. So we have a balanced chemical equation now. Now after writing a balanced chemical equation, since we are applying gay-lussac's law, the next thing to do now is to note the ratio in which each of the reactants are combining. And that can be gotten directly from the chemical equation. So here now we have 2 volumes of hydrogen gas. So we have 2 in the ratio of 1. So now because we have 1 volume of oxygen gas reacting with the hydrogen gas, so then in the product side we have 2 as well for the ratio. That is, if 2 volumes of hydrogen gas or 2 moles of hydrogen gas react with 1 mole of oxygen gas, it will give us 2 moles of steam. So now let's proceed. After noting the ratio, don't forget that they do so in simple ratio. So now the ratio in which hydrogen gas and oxygen gas is combining here is 2 to 1. So now this my ratio of 2 to 1 can also be, I can also put it to be 2 volumes ratio 1 volume. The 8 cm cube of hydrogen given can also be regarded as the volume of hydrogen, since centimeter cube is unit of volume. So we then say 8 cm cube of hydrogen gas, we then require X centimeter cube of oxygen gas. I'm using X here because we are yet to determine the volume of oxygen gas that reacted, and that's the first thing we need to know for us to know the remaining volume that will be left if 20 cm cube of oxygen is being provided. Now since 8 cm cube of hydrogen gas is being used up, then what volume of oxygen gas will be needed for the complete reaction? So now to get X, now we'll just say X equals 8 cm cube times 1 volume here divided by 2 volume. So this gives us 4 cm cube. That means 8 cm cube of hydrogen gas will require 4 cm cube of oxygen gas for the complete reaction to take place. So now if 4 cm cube of oxygen gas is being used and we are given 20 cm cube of oxygen, what is the volume of oxygen gas that will be left at the end of the reaction? So to know the remaining volume of oxygen gas, let's note that volume of oxygen gas that reacted equals 4 cm cube. So remaining volume of oxygen gas will then be equal to the initial volume of oxygen gas that was given, which is 20 centimeter cube, minus the volume that reacted, which is 4 centimeter cube. We can also take this to be initial and final values. So this gives us 16 centimeter cube. After reacting 8 centimeter cube of hydrogen with 20 centimeter cube of oxygen, 16 centimeter cube of oxygen will remain, and that answers the question perfectly. Kindly subscribe to this channel and also click on the notification bell so as to get notified as soon as new videos are being posted. Thank you.